Hello everybody, this is the problem in which we are asked to find the two level forms of logic, okay, for the given Boolean function. So this is problem 3.24 from Digital Design by Moris Mano's 5th edition. So let me read the question first. Implement the following Boolean function f using the two level forms of logic A NAND and B AND NOR, C OR NAND and D NOR OR. And the function f of a comma b comma c comma d is equal to sigma 0, 4, 8, 9, 10, 11, 12 and 14. So what is given if you analyze this problem? We are given a function f, isn't it? So it is given as summation of the minterms. And we are asked to implement using two levels. So that is the question given for us. Two level forms. What to do now? So first we need the help of the schema. So we do the simplification. So once you simplify, you will get the simplified expression. You have to get it in two forms. One is the SOP, another one in POS format. Okay, so SOP means it is by combining the ones you get it, and this is by zeros you will be get it. Okay, and the third step is we are not going to directly apply this SOP for the implementation. So our next step is going for implementation, isn't it? But we are not directly applying. So in this implementation, the important part is applying De Morgan's here. Applying De Morgan's theorem. So if you apply it, then only we'll get it in the required format. So if you have some a plus b the whole dash, it should be written as a dash dot b dash. Okay. And if you have this a dash dot b dash, then you have to write it as a plus b the whole dash. Similarly, if you have the other form, that is ab the whole dash, then you have to write it as a dash plus b dash. Then if you have the format like this, a dash plus b dash, then you have to write it as ab the whole dash. These four are playing the most important role in getting the two level forms. So with this introduction, let's get started. So for this f of a comma b comma c comma d sigma 0, 4, 8, 9, 10, 11, 12 and 14, we have marked the ones. I am not going into the details because it will take a lot of time, and if you want to know how to simplify or how to apply this in the K-map, you can refer the previous or earlier videos regarding K-map. Okay, so here we have this many number of ones and we have grouped them as three loops, loop 1, loop 2, loop 3, and we got this expression c dash d dash a d dash and a b dash. Okay, so we have written this SOP, sum of product form, as c dash d dash plus a d dash plus a b dash, and we are going for the rest of the thing, that is remaining cells which are not filled up with the ones are now filled up with the zeros, and we are grouping the zeros so that we got three loops, loop 1, 2, 3, and we got the corresponding expression, and we got this f simplified also, that is a plus d dash added with a plus c dash added with b dash plus c dash, b dash plus d dash. So we got the simplified expression in POS form also. Okay, these two are the first requirement for getting into drawing of this two level forms of logic. Okay, implementation of that logic. So now we are moving on to the second step. So we got this POS first, we have taken this POS first, a plus d a plus d dash added with a plus c dash added with b dash plus d dash. So we want to implement. So I am taking this as f1 in which I am doing some modification. What are all there? So this is a plus d dash. Okay, then I have to write it as a dash d the whole dash. So it is also, you have to always remember that De Morgan's, isn't it? I have already told you that a plus b the whole dash, if it is there, then you can write it as a dash b dash. If you have ab the whole dash, then it can be written as a dash plus b dash. Okay, so this is coming under this plus, right? So something similar to this plus. So what do you need to do if you have this plus kind of thing? This is applicable here. A dash plus b dash. So we are taking this and we are converting it here. That means we have to invert this a. So you have to invert this a dash so that you get a. You have to invert this b dash so that you get a b, and then you put the whole dash. Okay. So we are taking this term first. In this term, you have to complement each and every literal. A is converted to a dash, d dash is converted into d, and this operator is changed to dot, and then over, okay, to this bracket you have to put a over bar, right? This is over. Now you go to the second term. So here a is converted to a dash. That is, we are applying De Morgan's for each and every term. So a is converted to a dash, this plus sign is converted to dot, and this c dash is converted to c. Then apply the whole bar, whole dash. Then you take this b dash plus d dash. So this is complemented, so you get b. Then this plus is converted to dot, d dash is converted to d. Then you put the whole dash. That's it. If you get it, now we can easily implement this, right? So how to implement this? You take this a dash d here. So they are given to a NAND gate because this term can be implemented using NAND function. So NAND gate. This is for the first term. Then a dash c the whole dash. So again a NAND gate. Here a dash, here c. Then it is given to a NAND gate. So this is your second term. So you get this as a dash c the whole dash. Similarly, the third one can also be implemented using a NAND function. So you get it as bd the whole dash. Then all these three terms are combined using dot product, okay, dot operator. So it is served by this. So it is served by the AND operator, AND gate. So here we have this NAND for each and every term, and these three terms are combined using AND. Then you are getting this F1. Okay. So what logic is being implemented? If you check, it is NAND AND logic. Okay. So here first, this is your first level. Up to this we get this first level, isn't it? This is your first level of logic where we have applied this NAND, and this is your second level. So this is first level and this is your second level. So we have two level logic. Okay. So we have implemented this using NAND and logic. So the first thing is over. Then we move on to the next. Now we start with this F1 again. Okay, F1 is what? A dash d the whole dash, a dash c the whole dash, bd the whole dash. So for this again, these terms we are going to apply, these three terms we are going to apply the logic. Okay, what logic? For this function. So for this function we are going to apply De Morgan's on the whole. So what we do, a dash d, then here you have this dash, isn't it? The dash is replaced here because we are taking the complement. Then this dot is here replaced by plus. Then here also you have this dash that is removed here. Then this dot is now replaced by plus, and on the whole we have no bar, but this bar is provided here. Okay. So you will be getting this second function. What is the second function? It is a dash d plus a dash c plus bd the whole dash. So when you apply, you will get this f1 function. So f1, f2 and f simplified in POS all are related. Okay, all are the same. So they start from here only. Okay. So now we can implement this f2 function. So here if you see, this can be implemented using an AND gate a dash d, and this a dash c can be implemented using another AND gate. This can be implemented using another AND gate, and these three terms are combined using this plus operator, isn't it? They are combined using the plus. Plus means or. These three are combined using this plus along with the dash is there. So that represents NOR operation. Okay, so everything is plus along with that dash inversion that indicates it is a NOR operator. So we have formed this logic, and this is your first level up to this where we used AND gates, and here in the second level we are using NOR gates. Okay. So this thing is much important. The implementation is easiest part, but how you convert this Boolean functions or simplified Boolean functions into its equivalent De Morgans, by applying De Morgans, how you are converting it into NAND and logic or NOR logic, something like that. Okay. So this is what AND NOR logic. So we have implemented the second one using AND NOR logic. AND logic is for the first level, and the NOR logic is used for the second level. So now we move on to the SOP, sum of product. So this also we have obtained using K-map already as a first step, and this C dash D dash is taken and it is complemented, so you get C plus D, or we are finding the dual, right? So it is taken as C plus D the whole bar, right? And this term is taken, and for this we are applying De Morgan, so you get this as A dash plus D the whole dash, and for this we are applying, so it becomes A dash plus B the whole dash. In between the plus sign is there already, we didn't disturb it. Okay, we haven't disturbed that particular sign and all. So here what it is NOR function. This is NOR function because plus is there along with the inversion is also there. Okay, so it is NOR. So first level is NOR, and then all this NOR gates are combined using this plus operator, isn't it? So we have the functionality. This is your first. So this is the first level that is implemented using NOR. So it can be easily implemented, isn't it? C, D, they are ORed and then inverted means NOR. We are going for the NOR. So we have 1, 2, 3 NOR gates available in the first level, and they are combined using this plus operator means OR. Okay. So this is your second level. Up to this it is first level. Up to this it is first level. Okay. Then after this line it is your second level. So it is actually the NOR OR logic. We have already seen, but we have just named it. Okay, this is also asked in our problem. We are moving on to the fourth logic, that is derived from this F3 third logic only. So in the third logic we got this as C plus D the whole dash plus A dash plus D the whole dash plus A dash plus B the whole dash, right? So these were already, F3 was already derived from this SOP, isn't it? So now what we are doing is, for this again we are applying the De Morgan's theorem, right? So this C plus D, this dash, this complement is removed and this plus is changed to dot, like that we have that. Okay, so A dash plus D, the dash is removed, the bar is removed, and this plus sign is removed, and we put the whole dash. Okay, so we got this as C plus D into A dash plus D into A dash plus B the whole dash. So when you apply De Morgan's for this, we will get this F3. So if you apply De Morgan's for this F3, you will get this F4. Okay. So both are interrelated only. So for this F4 function, we'll implement using logic gates. Using logic gates, we implement this F4 function. So it is CD that is given to a OR gate because it is related. They are combined using this plus operator, isn't it? Then when you go to the second term, here also A and D are combined using this OR, that is plus sign. So OR operator is used. Okay, OR gate is implemented. Then for this A dash plus B, again we have the third OR gate. Okay. So 3 OR gates are used to implement this. And again when you go for these terms, first term, second term and the third term, they are combined using this dot. Okay, and then one dash is also there. That means it is dot with a dash inverter, means it is NAND function. Okay, so we have implemented this using OR NAND logic. Right. So we have implemented the same function using 2-level logics in 4 different 2-level logics. Okay, thank you. Hope you have understood.